Well, we just clicked over to 12:04, so that was the time when I said that that we would get started. I'm Jay Gentry. I don't think I show, but I may. But I'm Jay Gentry. I'm on the board of Passive House California, and we are sponsoring this, or we're the initial sponsor. I'd like to first thank very much the Central Coast Climate Collaborative and the Tri-County Regional Energy Network for being co-sponsors with us and helping with the parts. In particular, 3C Ren is doing the AIA point, the continuing education portion. So we really appreciate the help that we've had there. So go to the second slide, if you would, please, Matt. Your presenters today are Craig and Beth. You've had that was in the information earlier, so you could read it. I'll point out just a couple of things. Is 27 years of estimating, management, and delivering projects like this. And the combination or the fact that between them they have 11 different green certifications or high performance certifications. And click, if you would, Matt. I, by the way, have known Craig and Beth for a while, and I can tell you that they really are smart and very committed to what we're doing and to saving the planet, so to speak, with the built environment. They came together and in 2017 co-founded the Oros Group. And 2 years later, wrote The Power of Existing Buildings, Saving Money, Improving Health, and Reducing Environmental Impacts, which is pictured there. I imagine there will be a lot of good questions. We will be following the chat, but if you have a question that is definitely worthy of, you'd really like answered at the end when we're in the question and answer section, please go ahead and put it into the Q&A so it calls our attention to. With this many attendees, it's going, the chat's going to be pretty active. So put the really important questions in the Q&A for us. And with that, I will we'll turn it over to Beth and Craig.
Great, thanks, Jay. And based on this really great list of participants, attendees, you are one of the most well-networked people on the planet. So thanks to all of you for accepting our invitation, Jay's invitation to join us for a conversation on evidence-based performance. We're all thinking the same thing in this world of the built environment, and that's how do we build the highest performing building at the lowest possible cost. And we're going to go through kind of how to think about evidence-based performance in a way that empowers you to make choices and to be aggressive when it comes to sustainability. I want to take you from thinking about designing a building, though, to operating one. And I want you to make kind of this mental shift in your mind from not so much the design process, but very much about how do you measure success. This is one of the only industries where you can spend maybe $100 or $150 million on a building and not be entirely sure what you got in terms of performance. And so we want to answer questions like, did I get what I paid for? Did I meet my goals? Did I achieve success? So not only are we going to channel Wayne Gretzky today, and for those of you on the West Coast, I find that particularly appropriate, we'll channel Wayne Gretzky and try to figure out, where the puck is going. And we do that because if we have a better idea of where the puck is going, now we feel confident of requiring our teams to get there. So in the end, not any one of us delivers against these objectives on our own. It takes really a village, right? It takes a lot of people aligned on a common mission to deliver against goals. And evidence-based performance is the great equalizer. We talk a lot about today in this world, the democratization of data. And so we're going to talk a little bit about what that looks like in the built environment. So we want to know how to hold teams and ourselves accountable for achieving targeted results. But each one of us comes into this conversation with a compilation of experiences. Some of you owners and developers, paid green to set green goals, and you're not entirely sure you got green results and you paid back at all. Others, you might be really anxious about how do I take that first step? What's the no regrets move I can make? And then still others of you might be thinking about, is the hill worth the climb? Are the benefits really worth the risks associated with some of these ideas? But our objective today is to develop the confidence that you boldly step and demand your teams boldly step with you. That's our objective today. Evidence-based performance makes it possible to reach high performance without spending a premium. in the cost of construction. And we're going to go pretty detailed into why we feel that way. But we start with, what is it? Well, it's these things. And what you're going to see is it's a lot of specificity around data. It's a lot of very tangible things. And it uses building science and data science to empower decision-making. So, if you think about it, the more data you have, the more detailed that data is, the earlier you have it in the process, the higher quality decision you can make. And so evidence-based performance really starts with, how do you get that level of detail? Now, do we need it? It's a whole different question. And so to answer that question, we have to spend just a couple of seconds thinking about the history of sustainability in the built environment. It started in the 70s with conservatism and activism, and then went into prescriptive standards like LEED, and then evolved into performance standards. But today, it's about performance accountability. And if you are somewhere in the world where there isn't performance accountability, it's coming. And it's coming fast. And it's coming because more and more building owners are being held accountable to two things: environmental health and human health and well-being. Those are becoming imperatives. And so when you think about kind of, do we need it? We believe the industry disruptor is performance accountability. How do we reach it? And what's the first step to take to get there? The answer to those questions are exactly the same. And Stephen Covey laid it out beautifully with, we have to begin with the end in mind. Ergo, why I asked you to switch from thinking about design to thinking about operations. And so when we think about owner's project requirements, it's a term that's been around in the industry for a long time. And owner's project requirements really kind of started out as almost being like a strategy document. It was a lot of narrative. Where the puck is going is it's all about metrics. And why is that? Because the easiest way to align team members, think about your team members, architects, engineers, commissioning agents, the best way to align them on a project is to metrics, not to words. Words leave so much open for interpretation. It creates paralysis on teams. Metrics gives teams the chance to bring their expertise to bear and come up with the 1 + 1 = 3 or 1 + 1 = 5 solutions. So at this point, all I want you to think about is that owner's project requirements should never be about words. It should really only be about numbers. And those metrics should demonstrate what's expected performance in operations. Again, how are you going to define success when you're operating? Before we click deeper on evidence-based performance, I want to come up a level and I want to talk about sustainable development. This is a conversation we all have in our little circles and with our friends and with our coworkers. What is sustainable development? Academically, they talk about the Venn diagram on the left, right? If you do these things, you should be in the world of sustainable development. The UN, from a socio-political standpoint, said, no, we have our sustainable development goals as they pertain to the built environment. But as practitioners, we have to find the things that are actionable. We have to kind of parse through all of the language, all of the words to find out how do we set goals that are going to matter. And so for us, what we say is, hey, find what's actionable and really the two threads that weave together. All of the goals in the UN SDGs are reduce or eliminate fuel poverty and drive to equitable indoor air quality. And so those threads are really values. And those values underpin the choices that we make. And so if we're really good, our goals will align with our values. And when they do, we know we're moving the needle. Now, we believe any building can be high performing. An existing building, a new building, doesn't matter. We believe any building can be high performing, but to do so, you have to know and understand and find a building's potential. And a building's potential, new or existing, is found by merging the digital with the real worlds. So simulation that meets up with trended data or expected data. And so for us, we think this is where technology begins to reduce the risks of boldly stepping forward with sustainability and sustainability type goals. But there are different kinds of technology, right? So Craig's going to go through this in a whole lot more detail a little bit later on in the presentation. But to achieve evidence-based performance, it requires building science and data science. And we can't really conflict the ideas of high performing and smart. There's a lot of conversation about intelligent buildings, right? You can have a really smart or intelligent building and have it not be high performing. So there's all kinds of technology available to tell you everything there is to know. But we need to take a surgical approach to choosing what technology to employ based on what we expect it to deliver in operations. So again, we align the thought of high performance with using data from an Internet of Things standpoint, or smart buildings, intelligent buildings. We align those goals to what we've set as metrics along with our values. Now, we continue to try and drive with a process that will get us the highest performing building at the lowest possible cost, right? Because we're getting really laser sharp and laser focused. We want to find that sweet spot between high performance before we have to pay any premium in the cost of construction. I want to stop for just a second and make sure we're aligned and landed on terminology. Energy use intensity, water use intensity, these metrics exist to compare buildings and their performance one to another, much like how miles per gallon to a car gives you the idea of how what the efficiency is, the fuel efficiency of one car versus another, or one truck versus another. So for us, setting goals and getting to a really robust goal setting process isn't just a piece of something, it's everything. And no special skills are required to do this. So any building owner and any developer, any team member can sit down and think about, how do we articulate the goals of a project against what we want to measure, what we want to define as success in operations. But we need to cast a really broad net. So I'm going to run through a very quick review of a subset of standards and certifications. As Jay mentioned, we're certified in everything because we never want that to lead our thinking. We don't want to come to a problem with a solution, right? If all you have is a hammer, everything looks like a nail kind of thing. We don't want to come to the solution because that happens to be the certification. We want to be agnostic and indifferent. And there are a lot of practitioners in the space that think the same way that we do. This is not unique to Oros Group. But it's important to understand as we go into kind of this next part of the conversation, we're not marketing or trying to push any particular program. We're trying to get to how do you think about evidence-based performance in a way that gives you the most performance at the least cost. That is going to require thinking about the buffet. And for those of you on the West Coast approaching lunch, I'm really sorry, but I want you to envision a really bountiful buffet, because we're going to go through a bunch of standards that are going to show you various items on the buffet. So we want to know where the puck is going, and we think the buffet is where the puck is going. So we're going to start with LEED. LEED is kind of the granddaddy of all standards, right? The world owes a debt of gratitude to LEED. 20 or so years ago, LEED really kind of put the path in place for what it means to build a higher quality building. What does building performance mean? And it was all about building design and what to consider to build better buildings. If you could go to the next slide, Craig. So it was a framework about how to build better buildings. So LEED gave us our start, right? LEED was where we started. Since then, other standards have used various approaches to build broader standards and sometimes more narrow or more focused standards. And we're going to talk about both in the course of the next few minutes. We're going to talk about both types, and then we're going to kind of wrap it up and explain why that's so important to understand the vantage point from which these standards come as you think about setting goals. So ILFI created the Living Building Standard, which is based on ecological research. And ecological research is all about the study of relationships between living organisms and their environment. And it's not just living organisms inside the building. It's living organisms outside the building. It's the environment outside. It's the environment inside. Living Building Challenge really has casted the broadest net of how to think about building performance when it takes an ecological point of view. It has about 7 petals, and they're grouped broadly along what you can easily call values, right? So they look at values and they think about what all the elements of this ecological approach, all the pieces and elements that would fit into place or beauty or equity. And so they take a values-oriented approach to goal setting, and there are various pathways to reach living building certification. All of these, even the ones that look the simplest, because of how broad living building sets its vantage point, how broad it sets its interests, each one of these requires a deep commitment. It's very rigorous, and your commitment to individual petals or combinations of petals has to be based on that value. So again, it's really important to think about how your goals align with your values. Well says, well, we've spent 90% of our time indoors, so we're concerned mostly with one interface, and that's the interface between buildings and their occupants. Well is based on medical research, but it's based on individuals. So well looks at how does a building interact with our individual, our own persons, body systems, our human body system on all of these levels. That's the research that Well brings to the table. And so when you think about the comprehensive approach to Well, it's broad similarly to living building, but it's not as broad. It doesn't take on as much space as living building does. So it's got 10 concepts, over 100 features, where Well has teeth is that each one of the concepts has prerequisites. And so if you blow a prerequisite, a lot of times in Well, you blow Well. And so there are some teeth associated with Well that are kind of distinctive. But Well does absolutely the broadest and deepest job of understanding that interface between a building and an individual occupant. Now, the middle of last year, Well came up with the Well Health and Safety Rating, and we mentioned this because it's a little bit different than how it approached the broader Well. This is really much more narrow. It's focused on policies and intentions. It was in response to the pandemic, of course. It's had a lot of publicity and press, but it's intended to give building owners and developers the pathway to tell occupants we're controlling for what we can control. And so that was really the purpose behind Well Health and Safety. When we look at Fitwell, Fitwell is based on public health research. And this is a big distinction between living building, Well building, and Fitwell. Fitwell says, the biggest impact we can make on the built environment and people in the built environment is to look at chronic disease and chronic conditions. And anytime you think about public health and chronic disease or chronic conditions, it's about populations in general, not individuals. That's where Well is distinctive. So Fitwell says we want to look at the health of populations, and we want to look at chronic disease like heart disease, asthma, COPD, obesity, hypertension. All those kind of things go to what Fitwell is concerned about in terms of how people operate and interact with a building and with each other. It's considered the more approachable standard due to its flexibility. So Fitwell has 7 health categories, and there are no prerequisites. And so it's considered basically to be the most flexible. And just recently, in the middle of 2020, it too came out with a response to the pandemic. But this was Fitwell's first foray into infectious or contagious disease. Fitwell, prior to viral response, had really only been about chronic disease. So they take a very similar approach to Well Health and Safety in that they set, basically expectations around policies and intention with the purpose of ensuring that occupants know that owners and developers are controlling for what they can control. So those standards really direct the strategies that are necessary to achieve certification. The next 2 standards we're going to talk about, and remember again, we're having this conversation because we're trying to get after goals and metrics because we're trying to get to evidence-based performance. What separates these next 2 standards is that they don't tell you how to get to a result. They merely define the expectation of the performance in operations. And so Passive House is really unique and is worth talking about. It's an interesting story, right? Because the concept around Passive House actually has the oldest roots. So when Passive House first was kind of conceived by Dr. Feist in Germany, it was all around the notion, it was way back in the 70s, and it was all around the notion of hygiene ventilation. And so what most people don't know is that hygiene ventilation, the idea that we never breathe the same air twice, I think you have to just kind of click through all of these, Craig, for whatever reason. I think this just unfortunately flows through. So just click them all through so everybody can see the general graphic. But what most people don't know is that, Passive House started its roots really trying to define hygiene ventilation and how do we never breathe the same air twice. However, what Passive House showed is that there was dramatic energy savings. And if you remember back in the 70s and 80s, that was what was newsworthy. What people wanted to hear about is look at how much you can reduce energy in these buildings. However, today, there's as much interest in indoor air quality as there is in energy. And so Passive House really enables the conversation about both. So the idea of integrated methodology where there's continuous insulation, continuous air barrier, thermal bridge free connections, high performance windows and doors, high efficiency heat recovery ventilation, these things all begin to define from a principle standpoint what's important, what are the key criteria or key things that you want to consider and think about in order to get to what they define, which is the performance. What they're not going to do is say you have to use these windows. They're not going to say you have to use this HRV. They're just going to say you have to achieve this kind of level of performance. So in this next slide, you can see what's possible in terms of performance. So I wanted to set out kind of some basics around EUI in the very beginning, because the chart on the left gives you kind of an idea of how EUIs differ by building type. And Passive House says we know organically that every building should really be able to reach something like a 14 EUI. And so, what comes out of Passive House is this idea of the natural order of sustainability. It's a little like the order of operations when you learn math, right? Multiplication and division before addition and subtraction, right? So it's kind of the same order of operations. You want to take passive systems first. You want to build the highest performing envelope that you can build, because what that allows for you to do is reduce the size and complexity of your active systems. The cost trade-off should be similar. You might have to pay a little bit more in your envelope, but you should pay less in your active systems. The two together create the environment where you can spend the least amount on renewables to get to zero energy. That's why, for example, the city of Pittsburgh, when they talk about zero energy ready, the city of Pittsburgh is saying, listen, work all your consumption down. Get your consumption down as far as you can using passive strategies and active strategies. Then when we are at zero energy ready, we know we've got the least amount of distance we have to move to get to zero energy. So it's the most cost-effective approach to getting to really tremendous results like zero energy. So the 5 methodologies of Passive House really conspire to deliver one thing, and that's a high-performing envelope. The envelope delivers control. And when you have control, again, it kind of sometimes gives me tingles when everything like lines up beautifully, right? So here we go again, we're lining up beautifully. When you look at the left, what we're trying to do is reduce lost energy, right? The Jay sometimes gives an example of a thermos that you shove pennies in. That thermos isn't going to hold its insulation capabilities if you shove in pennies through the side of it. So we want to reduce lost energy, and we want to protect the indoor environment from the outdoor environment. That's the benefit of the envelope and a high performing envelope. But here's what's really cool. We've now just defined and aligned with our values. If our value is reducing fuel poverty, and our value is equitable indoor quality for everyone, wherever they live, work, play, learn, these fundamentals of building science really help drive to those end games, to those goals. So while Passive House provides the building science to get to both really low energy and indoor air quality, it sets it, or for energy, because it sets the bar so high, meaning the EUI is so low for what's possible from an energy performance standpoint. Reset Air does the same thing for indoor air quality. Reset Air sets the highest expectations around indoor air quality performance of any standard, but it goes steps further than most of the other standards. It goes steps further because it says what's really important is data. So there's what the indoor air quality is, and then there's, are you making it available for people to make their best decisions? So Reset Air says, yes, we have to have high quality monitors. Otherwise it's garbage in, garbage out. We need to know that the monitors that are measuring the air quality are of a certain quality and capability. They layer on top of that the standards around where you place those monitors. How many do you need? Where do you locate them in a particular room versus another room? So they set expectations for that. Then they add on to that, now we care how you manage your data. So to get Reset Air certified, this is the most rigorous and robust process you go through because they also deal with the data. Again, let's go back. To deliver against goals, to set your goals really high and deliver them at par or the cost of construction, we want to use the best thinking in building science and the best thinking in data science. And all of these capabilities exist today. So when we go to what does Reset Air actually measure, it measures PM 2.5, total volatile organic compounds, carbon dioxide, temperature, relative humidity, and carbon monoxide where it's appropriate. And it sets the most aggressive targets, those high performance targets that you see on the bottom in blue. Those are the most aggressive targets of any standard. The cool interface between Passive House and Reset Air is that we focus on performance where it matters. Inside the building and at the level where occupants are living. So we don't concern ourselves with the things that we're not going to measure or we're not going to monitor, that we won't hold ourselves accountable to one way or another. Again, we stay aligned to goals and values and what we're going to measure in operations. There's one more layer of consideration, and I have to give all credit on this slide to Passive House Accelerator. And if you don't know what Passive House Accelerator is, go online to Passive House Accelerator. And at the bottom, if you scroll down on their homepage, you scroll all the way down to the bottom, there's a place where you can sign up for their newsletter. Passive House Accelerator is great for anybody thinking about building performance. They've done such a wonderful job of making this global community feel small and manageable. And what happens in Passive House Accelerator is the very best thinking, the very best problem solving, the very best comparison of best in class is done at Passive House Accelerator. So if you're not familiar with it, I encourage you to do that. They created this slide. They created what's called the natural order of decarbonization. So we have the natural order of sustainability, and that is the first piece on the left. What the natural order of decarbonization says is in a world where we're thinking about carbon, which by the way is very complex, I'm going to oversimplify it for example purposes, but it is very complex. You want to focus on embodied carbon at the same time you're driving energy efficiency. So everything we just talked about, what you needed to do early on in setting goals for energy, you want to do the same thing for embodied carbon, which is really a lot around materials, a lot around type of energy. Only after you get your most efficient, you've minimized your carbon, you've made your energy most efficient that you can get, do you want to think about electrifying everything. And then only after you've done that, do you want to think about renewable energy. So what happens in most cases today is building owners talk about renewables first. They haven't been through the natural order of operations. And so what you end up doing is overpaying, overcommitting, and really, kind of misthinking what your renewable strategies could be if you did these first three pieces properly and correctly early on. So the long way around the barn, as we say in Wisconsin, is that we get back now to how do we set goals? And the reason why we walked you through kind of this review of everything that's possible and how different standards consider different goals is because you want to align it to your values. You want to think about what's important to you. And then as you align goals and values, you can think about how do you do that. So take, for example, what I've circled here on this chart. So we think Passive House and Reset Air are foundational pieces of any project. And you don't have to necessarily commit to certification. They're so fundamental that then from there, you can pick and choose. This takes us back to the buffet. If you want the potatoes, you can take the potatoes. If you want the salad, you can have the salad. And so we think about, we might want the water piece from LEED. And Craig is going to, right after we're done with this slide, Craig's going to kind of walk you through a living example of what this looks like. You might want the social equity piece from Living Building. But what you're able to do is take a very surgical approach to setting your goals against the things that you're going to measure and the things that you actually want to be held accountable when that building is operating. What do you want to say defines success? So I'm going to turn it over to Craig, and he's going to walk you through a little bit more building science, goal setting, and data science.
Thanks, Beth. Hi, everyone. My name's Craig Stevenson. I'm really excited to be here with you today and talk to you guys about evidence-based performance. And evidence-based performance really starts and almost ends with setting your own goals. You can set your goals using sustainable certification programs. You can choose not to set goals, which in fact you are setting goals of code-based strategies, which is sort of what we refer to as racing to the bottom. Or you can set more aspirational goals. And then the question becomes, when you start setting goals, how do I manage those goals? So the OPR is really kind of our foundation and how we start the conversation on our project teams. And we think that every project team should utilize a goal setting tool like this. An OPR is a living document. It's intended to be updated. It's not cast in stone. We do it really early in the project, and it helps to get the architects and engineers aligned around where the project is going, getting buy-in from the client. It's super important. And we create what we refer to this as a baseline OPR starting the project out. But as you go through design, you'll find, just like on every other project, you have your challenges. You'll have your financial challenges. You'll have your constraints of schedule. You'll have your challenges by fundraisers and other things that come into the project. And at that point, you want to basically realign your goals, where you want to redefine them, but you don't want to throw everything out. I can't tell you how many projects we've been on where, the owner comes up against a financial constraint, freezes like a deer in headlights, and jettisons the entire sustainable package. We don't necessarily have to do that on these projects if we can set our goals up and start talking about this early. Goals can be based around sustainable programs. Goals can be set around metrics. And what we'll do through the next two slides is we'll talk about metrics. Before we do that, I just also wanted to remind everybody that what we're looking at here is an OPR for a particular project. So this is a single building. OPRs are really great tools to look at corporate-wide or portfolio-wide client-based goals. So if an owner has sustainability goals relative to carbon footprinting, or reduction in energy usage, or renewable strategies, those goals should be pulled into a corporate-wide OPR, and then OPR then becomes developed and it's ready to be deployed on a project-by-project basis. This way, when you start the project, you're starting with a foundation of what do we have. Then you can look at your constraints. Is it an existing building, more difficult to get really low energy? Is it a new building, more easy to get really low energy? Do we have financial constraints? Do we have other constraints that maybe are going to impact our owner's project requirements? So as you go through this, you'll start to notice that we talk very early about measurement verification. Why? Well, if we're going to set our OPR up using evidence-based criteria, we want to define whether or not we win or lose. So we start talking really early about, hey, if we're going to have an air quality goal in here, we probably should have an air quality monitor. If we're going to have an energy goal in our OPR, we probably should have an energy meter so we can at least understand whether or not we're reaching those goals. So we talk about measurement verification really early. Community-based goals, these are super important. Now, again, these can be measured without technology, but they can be measured. And what you'll notice is a common theme as you go through an OPR that's set up like this, built for an evidence-based delivery, is it's measurable. It's measurable early and it's measurable late. And we can start to set up some technology to really look at a lot of this, like energy, for example. These are passive house type goals you would typically see on a passive house project. Renewable strategies. We can set renewable strategy goals, but it's best to do that last, respecting the natural order sustainability, but at least identify that we are going to offset at some point. And if we are, what are we going to use? Are we using wind or photovoltaics or another form of renewable? Indoor air quality. When you guys get a copy of the presentation, you'll notice that a lot of these goals that you're looking at in here are built around the most aggressive goals for each of these metrics. These happen to be Reset Air because Reset Air represents the most aggressive, as Beth said, across every sustainable certification program. Reset Air has the most aggressive air quality thresholds, but they are achievable. And as we go to the second page of this example OPR, you can start to see indoor environmental goals, light and sound. This isn't Fulbright, this is an example OPR, but you can have certainly light goals on a project. Is it ambient light? Is it, what is our lux for artificial light? WELL does a really good job of articulating how those should be considered and thought about, the WELL building program it is. And then you have landscaping for beauty and biophilia. Again, Living Building Challenge does a really outstanding way of managing these types of goals. And you can start to go through and you'll notice in our OPR, we're actually referencing goals from different sustainable certifications. We're sort of, if you will, cherry picking our way through the best thought leaders, the best sustainable programs that exist for each of these different parameters of quality as you start to consider this. So the idea here is create our goals early, create an alignment and an owner buy-in, and then start talking about how do we connect these goals to some form of technology or feedback loop so we understand if we've met those goals. We like to think about energy and air quality because when you start thinking about how you achieve these goals, foundationally, the envelope really dictates whether or not you're going to be easily able to get to those. And the cheapest form of energy at the end of the day is the energy never used. So as we go through that, then it becomes how, okay? How do I, set my OPR? I feel really good about my goals. Everybody's coming out of our charrette, feeling energized, and we feel powerful, and we want to go tackle the world. Then it becomes when. How do I do this? Well, there's this McCleamy curve that we're showing here, and the cost of money is cheapest early. To move a door from one wall to the other is cheapest to do it, in conceptual planning or on paper. Once that door is installed, to move it is going to be much, much more expensive. So that's the same thought that we would argue that you guys want to consider when you start thinking about your owner's project requirements. We have to break down the silos of design, of conceptual planning, design development, contract documents, 100% documents, and we go into construction. We cannot wait until the silos to really determine whether or not we're meeting our goals. And what ends up happening on project teams is if you will, when you're chasing evidence-based delivery, is you'll start to see this iterative modeling, energy modeling, and iterative control estimating. We're making our biggest decisions on our projects most of the time in very early SD. When you start talking about massing and orientation of your buildings, if you have a new building, when you start talking about window to wall ratios, even for existing retrofits, when you start looking at your envelope optimization, those things are happening really early in SD. If we wait till the end of SD and we want to go back and talk about our envelope in DD, it becomes really challenging. Most foundational systems are kind of already set, and then all of a sudden we're set in our ways and we can't go back and change. It's a commitment early to the goals. It's using iterative estimating and modeling to start identifying what can we do early. And you'll notice that as you come through this design development, SD and DD into CD, you're going to make those decisions really early, and you're going to find yourselves realigning back to the OPR and making that working copy and updating it, and then figuring out how do I achieve the best bang for our dollar for these buildings. We're never going to advocate put your head down, go to pacify strategies, come hell or high water. We're going to advocate, using financial constraints. What is the best building we can build? And what we find over the last few years is you can actually get the passive house criteria and performance of buildings doing this really early and integrated, because the best ideas come out early and they're the cheapest ideas. So what's the map look like? And this really is your critical steps in the process of you start thinking about this, right? How do I get from point A to point B? How do I keep the project team energized and aligned? It takes a strong owner, an owner that's going to commit to an OPR and really have those conversations at every progress meeting, where are we at in terms of our goals? And then it takes a commitment to doing iterative modeling and iterative estimating early. Even if you don't onboard your general contractor early, you can use third-party estimating to start to answer those questions, because architects always are going to want to know the questions of differences between incidental values, differences between cladding, and how that wall is getting put together. Those have to be answered early. They cannot be answered in value engineering, quote unquote, when we get to construction processes. It's way too late for that. And then if you respect the natural order of sustainability and you're looking at your envelope first and your active system seconds and renewables last, you want to start to build out those specifications. And again, doing that really early in the process. And then you start to look to your integrated network, which is your feedback loop, your technology-based feedback loop in the buildings, to start getting those feedback loops built in. This smart building infrastructure, a lot of people think that, wow, I can't afford smart building infrastructure. Well, if you're into any kind of commercial building and you're putting in a proprietary BAS, we're arguing with you, you can afford smart building infrastructure. The macro trends in that industry are moving into open integrated environments, and there is cost feasible ways to put great feedback loops in buildings, and including reset air and other technologies to get those integrations between design and construction and operations. So when you think about that, and how are we going to start, connecting our feedback loops to our goals and targets set in the OPR, you need context, right? So, everybody looks at this a little bit differently. And if you've gone into any space on dashboarding and look at it, you'll hear them talk about histories. We use history to do that. And we were better than we were last week, or we're better than we were last year, or the average of the last 5 years. Or they use peer review like CBEX databases, and they start saying, well, we're a commercial office building, we're better than the CBEX by X%. Or they use simulation. The macro trend in the market is moving to simulation. Simulation is by far the most contextual. We can export from simulation all forms of energy dynamically into a dashboard, and this is what you're seeing here. And we can export temperature, humidity, relative humidity, and CO2 for buildings. So we have parameters for air quality we can look at as well. So the idea is, when you start to think about your feedback loops, how do we deploy meters and sensors, IoT, in a cost-effective way? And then how do we connect that to our goals and targets? We don't want to over meter our building. We want to meter our building just right to give us the feedback loops on our owner project requirements. And then the question ultimately is, did I get what I paid for, or did I meet our goals and targets? So when people talk to us and ask us about measurement verification, and this is a common question that comes up because a lot of people think that this is cost prohibitive, and we argue it's not. There are 4 main components to any measurement verification in a building. And the 2 things that really I want to align you on and have you start to think about is that 90% of our clients will buy the dashboard because it's the GUI, it's the shiny object. It looks really, really nice and neat. So they're going to basically go into the market and start searching and looking for dashboards that just have this really shine to them. But there's too many dashboards out there that we've seen that have no guts behind them, right? It's a great visual, but the data behind it's in jeopardy. It's on premises. It's not connected to the IoT in the way in which we want it to be connected. So it's coming directly from that and not being tossed through an analytic or a building automation system. But the real work here, when you start to consider this, is this intersection between the operational technology, the data aggregation point, and this historian. And how we get data into a single platform for, this single pane of glass concept. How do we start to get data into a position that we can use it to our benefit, and we can start to consider it for operations using analytics like fault detection and diagnostics or condition-based maintenance. So the deal here is that, we want our buildings to have a platform for meters and sensors that's flexible. Roll off the obsolete, roll on the new ones, and not take any hits at all. We want it to come through a converged network or a network system that's not going to have to change out. And it's not 10 networks for my BAS, my fire alarm, my lighting control. It's one network. It's a converged network that combines enterprise technologies and operational technologies of buildings. And then it is free flowing directly into our backend, our time series, real-time historian. And then if that's done right, you can use any number of 400 to 500 different ways to display that data through websites, through smart technology, through kiosks, back into programs for reporting systems. There's just lots of ways basically to share a data out of a real platform like this. And if you do it right, this open integration platform moves away from this concept of proprietariness or software services where you're paying someone a licensing fee to a platform that building owners can own, and it's theirs, and they don't need to ask for permission to basically go in. You can go in with the right credentials, the right experience, and the right capabilities to basically monitor this. So it gives you a lot of expandability and scalability across buildings. With that said, I'd like to just demonstrate a few case studies on how we've seen projects that are using evidence-based performance and how they created a lot of value out of that. So the project here is, this is a sports complex. It was a $30 million sports complex, has interior soccer fields, interior basketball courts. I think there was probably 8 basketball courts and 2 or 3 soccer fields. The intervention on this project to talk about performance didn't really begin until late in SD. So they were going through a traditional delivery before they sort of started to think about, hey, can I change the way we're doing business here and move away from a traditional delivery into something a little bit more performance-based? And they brought up a model and they were able to maximize in SD a lot of envelope first strategies. They were able to tighten up their building using air barriers and thermal barriers, a lot of passive house concepts. And you'll notice here, this is a pre-engineered metal building. So the pre-engineered metal building components were pre-engineered metal buildings. There's not a lot of intervention techniques in a pre-engineered metal building, but there was a traditional construction for all of the connected spaces. And that's where they were really able to see a lot of performance. At the end of the day, this building used passive house strategies that as an open integrated smart building. They achieved Reset Air certification and well building certification. They decided to go after Reset Air at the end of SD, and they still were able to achieve it because they were able to establish a much better building and that intervention point that they could bring in Reset Air. Well building, they didn't even try to go after well building until they were 50% of the way through construction. They figured, like, could we get there? And we looked at the model, we looked at the building, the entire team was engaged, and we were like, yeah, and they went after well building as well. So this is a project that the whole intervention for building performance started much later in the design process than it's preferred, but they were still able to get there. And this is a really amazing building. This project here is it's the home of the Sustainable MBA program for a business school in Pittsburgh. And this building here didn't really have a trigger meaning like new construction or major retrofit. Their trigger was they wanted to start to use their building as a learning laboratory. And working with this client, we said, well, what do you want to, what were your goals? What do you want to achieve? And they're like, well, we're an SMBA program, so we want our building to be zero energy, but we don't have enough rooftop for photovoltaics. But yet we renovate one slab, one floor every 2 years. We're renovating a floor. So what they did is they set about building a master plan, an EnerFit passive house master plan for every time they renovate a floor. Instead of ripping out an R12 wall and replacing with an R12, definition of insanity, right? Doing the same thing over and over and over again and hoping for a different result. They were able to start targeting what is their optimum thermal value and air value for this building. And through that, they were able to start making interventions into performance. But more importantly, they were concerned with getting the data from the building because this is a business school and they want to make a financial argument and improve financial models for sustainability. So once they connected their building to a smart building platform, the cohort is actually now using that building and its pedagogy as a learning laboratory to start discussing payback periods and alternative strategies for financing and how to build the real business model into transforming buildings. A 1950s building, by all accounts, underperforming from performance, not a real pleasant building to be in, and it's starting to transform now. This project is a project that did it right. They started really early in planning. They developed a robust OPR, a total engaged team from an architectural and engineering perspectives. And these guys went really for the holy grail. So they went after passive house, they went after fit well, and they went after Reset Air because they understand foundationally the envelope is the key to getting at all of the performance for indoor air quality and environmental conditions. The real big story about this project is not that it was able to do it, become a smart building and a high performance building. The key here is they did it for par. When the budget was set early on in the project, the owner established a budget for this of $30 million. It never changed. It stayed the same. We built out the OPR, it never changed. We went into the project, the architect was nervous at a few points in times along the way about, can we really get here? Can we really afford this? And as we kept pushing the envelope, no pun intended, on the performance goals for the project, we were able to make adjustments in different areas to make sure that we were able to meet their budget. And at the end of the day, this project is coming in on budget and doing everything that this owner wanted to do using evidence-based performance. And they did mix in a little bit of the certification programs, There was incentivization to do that around financial and everything else. But the point is that the sustainable certification programs did not lead the way. The owner elected to do that to its own benefit. They didn't need it to meet its goals. This project here is a project that's an 80-year-old cathedral. Hasn't ever been renovated. And they wanted to deal with, this idea of indoor air quality because of COVID and other reasons. This is in an impoverished neighborhood, and that neighborhood has a lot of asthma conditions. It's got a lot of air quality conditions, and they really wanted to show the neighborhood that you can use your building to change those parameters of your living conditions and of buildings. At the end of the day, they used passive house strategies. They certainly did not get anywhere near passive house performance. This is a cathedral with limestone inside and outside walls, so it had a lot of constraints on what we could and couldn't do. But they do have a smart building. It's open integrated. They were able to achieve the Reset Air standard, which is incredible. First cathedral in the world to do so, and they reduced their energy by 30%. And they've been operating this building now for a few years at those levels. Because they have the feedback loops in place. It's not to say they never came out of trend. You can see they came out of trend a little bit, and then they were able to basically bring the building back in whenever they needed to do so because they had the right feedback loops in place.
So, hey, Craig, go back on your slide because we have a question, and I think that slide is a great place for you to answer this question. Jamal's asked a few questions, but I'm going to get at his last one first because it fits with this picture right here. So he's asking, are we talking about a technology similar to digital twin here?
Yeah, so digital twins becoming that buzzword, right, that everybody hears and we don't quite know what it is, right? So what is a digital twin at the end of the day? And I'll go back here, Beth. I think this might do a better job of identifying what a digital twin is. A digital twin, if you break it down and you look at the twins that are out there like Thoughtwire and Willow, and they're doing a really good job, is that basically they have meters and sensors in the building and they have a way to aggregate their data into their database, and they're able to display a twin, if you will, of what the building is doing virtually versus the building physically. The difference between what we're talking about when we think of a digital twin, we see simulation, right? That's the true virtual environment. It's the virtual environment that I can interrogate. If the building goes out of trend in a digital twin, as it's known today, your intervention, I mean, you have knowledge, you know it's there, but your intervention's not really clear to you. Like, what caused it to go out? Is it my building automation system is now not set up for 8 to 5 and it's running 24/7? Is it a VAV? I don't necessarily know where it's at. Whereas I can go into simulation and I can start to create a lot of questions and interrogations and dropping those simulation targets back into the dashboard to really see where we're at in terms of how that building is performing. Digital twins are great. And digital twins really can enable an evidence-based performance discussion on a project. But think about digital twins and when they really come on board. A lot of times we see digital twins coming in as FF&E, like furniture, fixtures, and equipment. They come in with the IT at the end of the project when we're all said and done. Well, if we set our goals, then are we making sure we're taking that digital twin concept and connecting it back to our goals and targets? I think that that's the work to really see digital twins scale. We have to start to do. And then we also have to figure out, how do we not pay a duplication between a building automation, building management system and a digital twin? And we're seeing a lot of duplication right now because a lot of clients are bringing in digital twins because of their value, but they're missing the opportunity to remove the redundancies and the duplication of costs from control systems for your operational technologies.
So as a follow-up, don't go too far off those slides. As a follow-up, Jorge is asking, is the feedback loop or the historian digital twin related conceptually?
Well,
so go back to your slide with the 4 sections again. Go back to your slide. Yeah. So your real-time, what I think the question is this real-time database and historian the digital twin? And your answer to that is no.
Well, I mean, it's not directly related to it. Maybe that's a better way of answering the question. I think that there are some construction projects out there using digital twins that completely understand evidence-based delivery. and they've created a great OPR, and they're connecting their OPR to their measurement IoT. If they're doing that, then the digital twin would be related conceptually to what the project is intended to do. We've seen too many times that the IoT is deployed, we've selected our meters and sensors without regard to our OPR, and the next thing we know, we want to bring in a digital twin and lay it on top of the building like a layer, and it sits there as a tool that's not really quite integrated into the design intent, the engineering intent, and then the actual deployment of the meters and sensors in a building. And in that instance, that digital twin's a little bit disconnected until it has a chance over the next few years to burn in and have the owner figure out how to make that work.
So let me ask, follow on to that. Do most of the digital twins in the manner that you just described a digital twin to be, not a physics-based model, but more of a digital representation of an as-is building? Do those digital twins typically have a real-time database and historian capability to them? They
will, but the differences between what we talk about here is, like, we have this common theme we talk about all the time in our measurement verification: open, right? We don't want to be an SAS. We're tired of bringing in proprietariness to our building. We want to be open. So we want to have meters and sensors on a flexible platform, as we discussed. We want to have an open integration, operational technology, a data aggregation. We want our operational technologies like lighting control, security access, CCTV, density analytics, building automation. All those are called operational technologies. We want them to be open because we want to be able to access the data out of them without writing, expensive APIs or connectivities, custom software connectivities to their components. We want to basically be able to get the data out. And then we want to bring it into an historian that's open, that the client owns. This is their data. It's not your data. It's not our data. This is the client's data. They own this. In a digital twin, too many times I've seen that their database is proprietary. They're an SAS at the end of the day. So then the question becomes, is that the right place that I want to basically place my bet for the next 20 years? And I think there's a lot of openness that's out there right now, like an OSI soft Pi environment that provides far more capabilities for way less costs as compared to proprietary digital twins.
And then, so just to follow up from Dan, as someone not in construction, is the digital twin effectively a model of the building?
So there are two models we talk about in buildings. You have a BIM, building information model, and that's your 3D. Revit typically is a very popular three-dimensional building model. That's more CAD. Digital twins can take their data and show it in a CAD environment. But a CAD is not a real-time time series historian. It's just a way to connect and show data. So we can do that all day long. The time series real-time historian is the back end. That OSI soft Pi that I showed you is the historian that you would typically want to target when you want to talk about having a single pane of glass or a data lake to bring all that data into. Niagara has a really nice analytical platform. AWS has a platform. Those are, depending on which vendor is offering those services, they can be open and closed. So be careful when you start to look into those environments. And there are others like Coppertree, OSI soft Pi, like I said. There's a lot of, I would say probably 10 to 15 different time series environments that you can kind of look at. And again, as you do it, I would challenge you to think about it in terms of openness and access and not proprietariness.
So I will finish off these last two slides, and then we'll go back and answer all the rest of the questions, because we got some really great questions, Craig, and we can reference maybe some of our earlier slides to do so. But we promised kind of a framework of actionable steps, and so I don't want to miss these last two slides. So, these are the most meaningful things you can do on any project to reach evidence-based performance. You can delegate them to team members. So for owners out there, if you have an owner's performance advocate, again, where's the puck headed to in the future? Major projects will have owners' performance advocates for the purpose of identifying, setting goals, and then making sure that all team members are kind of moving together to achieve those goals, that the integration is there so that those goals are achieved in the most cost-effective way possible. So having an owner's project or having an owner's performance advocate to really oversee that work on behalf of the owner is where we see the puck going in the future. Whether it's one or many buildings, as Craig said earlier, for those of you who have developments and you're trying to figure out, kind of what comes first and what comes second, a lot of developments focus first on source. And we would argue that you really need to think about setting those goals and covenants around or your OPR for your site consumption. And then once you understand what your maxes are on site consumption, kind of building purpose by building purpose, now all of a sudden the path to source and the understanding how to deliver source becomes a lot easier once
Hey, Beth,
yeah.
For our friends in Europe, site energy use intensity is final energy, and source energy use intensity is primary energy. And it's the difference between, is it at the footprint of the building, measured at the footprint of the building, or is it measured from the actual generation point, like a electrical power plant or things like that. So I noticed we had some people that were from out of the country, and they may not be as familiar with our terminology around whole building metrics.
Yeah, that's great. So if you have, different members of your team taking on different pieces of this work, as an owner or a developer, or as a team member, you can offer to take on some of these things. There's no reason why a team member can't own and kind of take ownership over the development of an owner's project requirements on behalf of a project and an owner. So there are a lot of different ways, but these kind of begin to get you in the game on evidence-based performance. This is the framework of actionable steps.
I think it's also worth mentioning, Beth, that there is a best practices on the OPR to assign responsibilities to each of those elements. So as we went through those two slides and we went in deep to the performance metrics, if you get at something like sound, there is a responsible party. It might be an engineering for acoustician. If you're in light, it might be a lighting control contractor that's not necessarily your electrical engineer. It might be a lighting designer, so if you will. And it's really a best practice to assign a responsibility to each one of those OPR targets, so that as you go through the project and you have your meetings and you're talking about these, you can have a report back on it. Now, that doesn't mean that it's not multidisciplinary. It absolutely is, especially with the envelope, but it's helpful to have a champion, if you will, for each of those OPR targets so that they can own it and then work through the integrated multidisciplinary environment to make sure that the entire project team leans in on it.
That's great. In fact, that kind of answers one of the questions that we got in, but I'll finish off with this slide. So in a nutshell, evidence-based performance is a pathway to financially de-risking a project by holding teams accountable to meeting goals and metrics expected in operations. And so, from our perspective, if you want to ask, where does the whole thing start? It starts with the owner and the people closest to the owner's closest advisors, the building owner, the developer's closest advisors, and answering the question, how do we assess success in operations? What are we going to look back on and say, we killed it. We did a really great job. So that's where everything starts, but it is possible today. It aligns teams to metrics, and it proves that an owner developer got what they paid for. So you can flip to kind of the last slide, Craig, and we'll go through some of the questions that we got. I'll start with, maybe you could go to slide number 29, Craig. If you go to slide 29, which is our passive house, Chris Spychalski asked a question about saying that the slide saying renewables last. I disagree. If solar rooftop and maximum subsidies drive the decision, he's saying, maybe that's not true. And we would agree in that subsidies address first costs. In most cases, PV or solar rooftop subsidies are going to support kind of the first cost of installing those panels. What we would say is that for the ideal solution, so if you go back to trying to get to zero anything, trying to get to zero energy or trying to get to zero carbon, you want to first get your consumption down as low as possible. this tells you how to get that consumption as low as possible. Why? Because if you offset using PV, if you offset from a number much higher than a 14 EUI, eventually something's going to break. And it's not even just PV arrays or solar rooftops. It's a lot of other renewable energy too, in that they break. And when they break, the building reverts back to what its typical EUI would be. And so we would argue, even if you get subsidies, even if you can get the entire PV paid for, the long-term benefit, the operating costs benefit, is so significant and so meaningful that you're always going to want to do this. For us, this is almost like a no regrets move to do these things first before you get to renewables. But so, Chris, if you have something else to add to that, just pop back into the chat or the Q&A and we can take it from there. So then, Craig, if you go back to slide 35, and I can pitch a couple questions to you from Jamal. So Jamal's question is, do you think the gap between standards, meaning theoretical, and application, meaning practical, do you think the gap between those has been diminished, has narrowed?
I think I wouldn't classify it as a gap. If I was looking at this, I wouldn't classify it as a gap. I would classify it as a change in the way in which we look at buildings. We're moving away from prescriptive based standards. We're moving very, very, very quickly into evidence-based standards or performance-based metrics. And we're starting to see early indications of outcome-based criteria. If you look at New York City's climate action plan, for example, New York City has a climate action plan. It's legislation that all buildings must reduce its carbon emissions by 30%, or I'm sorry, 40% by 2030 and 80% by 2050. Doesn't care how. That's an outcome-based criteria. So I don't necessarily think that there's gaps. I do think that there's a lot of valuable insight, research. There's a lot of valuable white papers relating to all of these sustainable certification programs, and we respect them all. And that's why we kind of, select from those the best things that mean the most to our clients, and we use them. But it's moving away. So those standards that are still using checklists and prescriptive based criteria are quickly becoming obsolete. And we're starting to see a transition to performance-based criteria, more importantly to outcome-based criteria, which needs a measurement verification system to prove.
And so if we keep this same slide up, Jamal's next question is, what do you think of LEED and BREEAM compared to passive house standards these days?
So the way we look at this project, and I think there's a best practice here, Beth, maybe I can go to your slide. Let me find this slide that you always talk right here. So when we think about this slide here, the question becomes, BREEAM is more of a European standard. We don't see a lot in the United States. LEED, we certainly do. And the older programs, the programs that aren't really considering energy as well as others, are working their way top down. So if I have a hospital and it has an average EUI via CBEX or Energy Star Portfolio Manager of 197, right? What those programs are talking about is do 15% better than CBEX, or do 15% better than ASHRAE, which is our standard. And they start working their way down. When they do that, they are not able to tunnel through the cost barrier. And there is a cost barrier here where you have to get to a point where your equipment becomes small enough that your envelope starts to pay off. And that cost barrier works down here. So what we start with, and we think is the best practice, is identify either retrofit, or new buildings. What is the optimum performance of that building? What is the best? And take the metrics of cost off the table just for the quick early analysis. And once you do that, then look and say, okay, how far are we away from being able to afford that? And then work your way up. So if we start saying, well, I can't afford triple pane windows, but I can afford a passive house envelope, well, then what's the double pane windows do? As long as you're meeting your durability issues, right? The wall is still durable, it's not going to fail, and you're meeting your thermal comfort issues. Can we go to a window that's less expensive, and what does that do? So I'm making decisions from a financial perspective, but I'm coming up. And if we do that, you're always going to end up around 20 or 30, as opposed to starting at 100 EUI and coming down to an 80. And that's the main difference between the prescriptive programs that were popular in the past and the new programs that are starting to think a new way about doing this now. That's the biggest difference I'm seeing right now as they work their way up.
So then, you know, funny you mentioned EnerFit, because Jamal has two questions relating to EnerFit. The first one is about existing buildings in the UK. So his question is, passive house design standards might be too restrictive to be achieved in most of the UK's existing buildings for retrofit. Even though with the EnerFit standards, still many called hard to treat buildings are impossible in terms of achieving such requirements. And then he went on to ask, which maybe you might want to flip to the cathedral, because he went on to say, has the cathedral achieved EnerFit requirements? So it might be interesting for you to kind of answer both questions through the lens of East Liberty Presbyterian Church.
So we've been on many projects where we weren't able to achieve, for one reason or another, full performance metrics for, say, passive house, which is the most aggressive building performance from an energy consumption perspective of all the sustainable certification programs. We've been on many projects where we can't hit it. So we start using passive house strategies like the project I showed here. This project, because it had a lot of pre-engineered metal building connections, couldn't get to passive house building performance standards, but we use passive house strategies. And that's the same thing we did here, is we use passive house strategies. The failure points you want to be concerned about when you're using passive house strategies, and this is a caution because it could be a little bit challenging, is that you got to make sure that you're managing your wall durability and your interior thermal comfort. You do not want condensation to build up on a super insulated wall that hasn't been managed properly in terms of modeling. And you don't want your systems to be not right sized, but undersized, because you're losing more energy through the envelope than you originally planned. So using passive house strategies requires some experience, and it requires using someone who has a deep knowledge of building science, but it can absolutely be done. And to your point, there are many projects that simply can't go all the way to a full passive house certification or an EnerFit standard. And at that point, we would say that you can still work your way from the bottom up and still be 50% better than working your way from the top down.
Great. So there's a question.
Oh, I'm sorry, Beth. May I? One more?
Yeah, please.
Because they asked a question about the cathedral.
Yeah.
There's no way we did a thermal bridge mitigation or an envelope improvement at this cathedral. This is a limestone building inside and out. What we did is we didn't give up on all the passive strategies, though, right? Doesn't mean you have to kick everything out. What we did is the windows, they were the original windows, they're single pane, but they were very air leaky, right? Because they warped over the years a little bit. We went in and gasketed all of them. So we cleaned off there was aluminum corrosion on it. We were able to clean that off really nice and make a good surface for connection. We did that, right? So we were able to seal up all the windows and make sure all the operators worked. That was a big change. The second thing we did is we put ceiling fans in all the rooms. This building ventilates. It's amazing. On some of these buildings that were built this long ago, the architects understood chimney effect and how buildings breathe. And they were able to design in here almost like an economizer before economizers ever existed by using fans. So there's an exhaust fan and there's a supply fan. We simply returned the building systems to their original design intent, and the building ended up breathing. And now all of a sudden, all these times where they couldn't use the building in summer times, they're using it because we're moving the air through the building. We're using ceiling fans to move air. You don't need a 68, 72 threshold for these buildings, and this project here demonstrated that. The thermal mass alone, we were able to use night purging to bring in, free cooling overnight. The thermal mass alone was able to get us through a lot of times in the summertime that we simply couldn't get through in the past. So there is a ton of passive strategies that the team should consider, even an evidence-based approach to do efficiency. You don't have to kick it all out because the building is challenging. So this is a great example of using those strategies.
Beth and Craig, this is Jay. I think you can hear me. No one has asked this question, but a lot of times the question comes up in things that when I'm talking to folks about, there are a lot of parts of a team. There are a lot of members in there, your MEP, all the folks that are due. How do you get them to align and become aware of and become committed to get everybody to lean in, as you like to say. Could you talk a little bit about the process you use to get everybody on board and moving in the right direction?
Sure. So first of all, like I said earlier, data is kind of a big equalizer. Data brings people to a level of comfort and willingness to engage a lot faster than words do. There's still so much interpretation in words, and so many times where, you get people kind of looking at each other like, well, that wasn't me, that was you, and that wasn't you, that was me. And so, data has a really crazy way of bringing people together in a collaborative way. And it's got a little bit of truth serum in it. There's a certain amount of data you can't argue with. And so, the more you can rely on data, the more you can bring together this notion of building science and data science. What you'll see is the more you unleash and enable these cross-functional teams. You'll hit a point, you'll see a moment in time where you think you're up against it, like, oh my God, we got to come up with a solution for this ventilation issue. And then you start using the data, you start using the model, you simulate different results, you bring everybody together and you start sharing. And all of a sudden, what is unlocked is this idea of so many different potential options. And the brainstorming that takes place is really powerful. So in answer to your question, Jay, number one, if you are a team member on a team that is trying to do something more like this, have a little bit of faith, start with that, and then identify some goals. Set your sights on something, anything, and then bring the team together to try and problem solve something, and then set the next goal. And do the same thing each time you want to try to get to a different level of performance. From my standpoint, I don't know, Craig, if you have anything to add, but those are the kind of the key points I would articulate.
No, I think that's a great summary.
Thank you.
Hey, Beth, there's two other questions I want to try to get at. Under the one that Irina asks about can you talk a bit about the application of these strategies on single family home level? I can answer that really quickly. There is a gentleman, Matt Bowers, who's been blogging for years, and he's spoken at the North American Passive House Network's conference. He has a blog called Rochester Passive House. I think it's .com. If you Google it, you'll find it. Matt has been a practitioner of this for years, and he's someone that we've collaborated with on different projects because he just sees buildings in the same way in which we do. He's brilliant, really dedicated and passionate person about building performance. He has a measurement verification in his home that he deployed really for a cost-effective solution, and it's all on his website. So yes, we can do this a single family home. Matt Bowers has demonstrated that. His blog does a really good job of showing how he did it, and he is receptive to calls and emails. So if you email him, I know Matt will get back to you right away and give you some thoughts on how he did it.
I just dropped at least I think I did, his website address into the Q&A. At least I think I did.
Yeah, it might have went to answer. Do you want to throw it in the chat maybe?
Yeah. Yeah, I'll throw
And
it
then
in.
the other question while you're doing that, Zach asked a question about how relevant is BACnet nowadays in the new IoT API-based smart building systems. It's the most common protocol for data language there is, and it's very, very relevant. We use it almost on all of our projects. The key is getting the controller at the asset. So if you have a VAV, or you have an air handling unit, or you have a DOAS, direct outside air system, your air handling equipment, you want to make sure that when you buy that equipment, that it has a controller in it that's able to distribute data from it, typically BACnet, but there are other protocols. If you have an open integrated JACE, the OT that I showed you, that will communicate across all protocols. But the key, like I said, is making sure that when you buy those meters and sensors, that they can communicate back to that data aggregation point, whichever point you end up landing on. So yeah, very common protocol. It's something we see all the time.
And then I think Jamal is just asking, or maybe just offering a clarification on certificates. So just to be clear, on the cathedral, it did obtain the Reset Air certification, but we did not meet any type of ENERFIT certification per Craig's earlier conversation.
Yeah, it did not reach passive house levels of performance, but it did reach indoor air quality levels of performance.
So Jay, I will tell you, those are some of the most insightful and smart, intelligent questions and conversation we've had in a long time. And so I think it's just a testament to where our industry is getting to in terms of understanding these issues and opportunities, what they present. And we really appreciate everything that you did to pull all of this together.
Well, thank you very much. This is it exceeded my expectations. Your performance was, I had evidence that it was going to be terrific, but I really appreciate it. And I think in summary, we've got a couple minutes left, or well, 6 minutes left if there are further questions for people to bring into the chat or the Q&A. But I'd like to, I think everybody, or almost everybody on this on this webinar, we all agree what needs to happen with the built environment and with the planet. We also agree on why. We know the reasons that this is so critical to us in so many ways. And what you have shared today is a logical start to finish, begin with the end in mind way of how to get there. And to know where you're going. And then something that that you've said in the past that I really like is that if you look at a building's potential, and rather than and start there and say, okay, this is what it could be, how do we back down from there? Or as Craig said, what do we add at the bottom? It's so much better than taking and saying, okay, here's our budget. What should we do? Right. The idea of that is you just don't get to the same place. And it's everything working together as a system that I think is so important to being able to achieve the EUIs and the WUIs and the levels, the numbers that are there. They're just well done, and thank you very, very much.
I think, Jay, just to add to that, the people who I think are in the most challenging position today are the people who are trying to set goals and establish objectives for developments. Because there's no guidebook on this, there's no manual. And so there's this yin and this yang. There's this, tug, this torque between, the supply side of energy and the demand side of energy. And then indoor air quality is kind of caught in between. And so I think, and especially if we're talking California, where the consequences between the wildfires, water availability and the rest of that are so clear, that I think those are the people in the toughest spot. And we've worked on projects like that where, we really do believe the first thing to do is land on how to set goals and then how to hold people accountable, building by building, neighborhood by neighborhood, in terms of what's allowable. And when you do that, then all of a sudden kind of the opportunities open up, the options open up, and it becomes a lot clearer in how to get to where you want to go when you're looking at an entire development space or area or region.
Yeah, we have some big developments going on here. Would it be possible, or is it feasible for the group of policymakers or the elected officials or city councils and things to set a standard or a requirement, kind of a performance base, as opposed to a design guidelines, a performance guidelines for things that get built out that would make sense into there? Or I suppose even setting standards for a large company that has buildings all over the place about what we should do with it.
Jay, we've seen all too often companies setting carbon goals, and then we get on the projects and we start asking the project teams about them, and they look around the room and they're like, we don't know how to get there. We know that our corporate has these goals, but we don't know how to tie them back to the buildings. So I do think that there's this thought of how do we connect our more global goals, whether they be city or municipality or whether they be corporate, to an OPR, right? Start by connecting those first to a portfolio of your example buildings, and then connect them to your specific buildings, and then get yourself a feedback loop so you understand whether or not you're meeting those goals. That's the only way this is going to change. I do think that if you're looking for some policy example on how to do this, and our Passive House community knows this before I even say it, but Brussels is the model. I mean, Brussels went to Passive House levels for building performance based on code. And everybody knows the story that's been to a Passive House conference. You know, the first year there was a lot of friction. The second year there was less friction. By the third year, the market responded. Low flow equipment, Passive House materials. They're leading the market in terms of how their buildings have transformed. And I'm saying this very, very quickly. The presentation's an hour long, and it's one of the most interesting presentations that I've ever seen at a conference. That's how you do it at scale. It can be done. We're not reinventing the wheel here. The technology exists today to do it. We just got to think a little bit differently about how we approach buildings, and we have to break down our traditional silos. We're not going to get there in a traditional delivery. We have to rethink how we deliver buildings, and that integration, you know, lead as an integration component that you check a box because I had a couple meetings, and I'm oversimplifying that. But that integration is far more than that. It's real. It has to be real, or you're just not going to get there.
Thank you.
It's a great conversation.
Thanks to all of you. Thanks to everyone who attended, and of course to you, Beth and Craig, and a special thanks also to Matt Fedorko, who's our technology guy that makes it all work from beginning to end. And one more time, thank you to 4C and 3C Ren for your support in this. We really appreciate it. And let's just finish with something I learned from a very smart person that always signs his letters and emails and things with onward. So let's
Onward.
move onward. Thank you.
Onward.
Thank you, Jay. Thank you, everyone.
Thanks, everybody. Have a great day.